There's got to be a logarithm song, 'cause you've been getting all those logarithms wrong. There's got to be a way to see the answer to the mystery. No need for fear or deep lament. A log is just an exponent. Oh, the common log has a base of 10. Yes, a base of 10, but it's not written in. And the natural log has a base of e, but it's not written there, you see. So simply let it be. And the thing inside the log is called the argument. Yes, the argument. Let's start an argument. And the answer to a log is the exponent. Yes, the exponent. Yes, the exponent. The little number in the log is called the base. Unless it's 10 or e, it'll stare at you in the face. Now pay attention, watch the trick. I think you'll find this very slick. Raise the base to the exponent, and you will get the argument. Oh, the common log has a base of 10. Yes, a base of 10, but it's not written in. And the natural log has a base of e, but it's not written there, you see. So simply let it be. And the thing inside the log is called the argument. Yes, the argument. Let's start an argument. And the answer to a log is the exponent. Yes, the exponent. Yes, the exponent. Now when your friends, cousins, brothers, sisters, teachers, pals, or pets, I heard Uncle Joe, neighbor Sam say they have regrets, 'cause they all took math and never knew what a logarithm meant. Then you'll reply, a log is just an exponent. Exponent. A log is just an exponent. The exponents, we hope you'll find this curious. Know that logs are exponents, and we'll solve them fast and furious. Raise the base to the exponent, and you will get the argument. Now you know some log tricks, so we hope they're less mysterious.
All right, well, that's the end of that lesson. I don't know if that even's gonna work, but I don't know. I just wanted to experiment on that. Hey guys, welcome. 7.5 properties of logarithms. Hopefully, if you've been struggling with logarithms, that little jingle that you just saw, some of you are probably like, what the heck did I just watch? Will help you remember what a logarithm is, just an exponent. So properties of logarithms basically follow the same. If a logarithm is an exponent, they're gonna follow the same rules as exponentials. All right. So if you remember your exponential rules, you're gonna be fine with properties of logarithms. So let's look at the product property of log. So we know that if we have something like, so let's just relate this to exponentials. So if I have something like, well, let's use x. If I have x to the third times x squared, for instance, we know that when we solve this, we get x to the fifth because we add the exponents together, right? So the product property of logarithms is the same thing. So with logarithms, for all positive numbers a, b, and x, where x cannot equal 1, and we have this logarithm of a times b, that's the same thing as adding log base x of a to log base x of b. Okay, so addition relates to multiplication just like it did with exponentials. Okay, so here we have log base 2 of 5 times 6. I can break that up into log base 2 of 5 plus log base 2 of 6. So you're adding. Okay, so looks like I've already written something in here, so let me just clear this. Okay, so for this one, it says use log base 4 of 2 equals a half to approximate the value of log base 4 of 32. All right, so since we know that log base 4 of 2 is 1/2, what I can end up doing is saying, okay, that log base 4 of 2 Why did I write a 3? I don't know. Log base 4 of 2 times, if I multiply that 2 times 16, right, then that's the same thing as 32. So I can write this as log base 4 of 2 plus log base 4 of 16. Okay, so if I know that this is equal to 0.5, hopefully this evaluates nicely, and I think you'll see that it will. This is saying, okay, 4 to what power gives you 16? Well, that would be 2. So this would just be 0.5 plus 2. Log base 4 of 16 is 2. So the answer to this would be 2.5. Okay, so you can break these things up using that property that we just learned and relate it to nice things. So for this one, they gave us this, but if you weren't able to see that and they didn't give us this, you would, to solve this, you might want to just choose, okay, if there's a perfect square in here, given the base that we have, you know, like relative to the base that we have, then you can break it up into nice pieces. The quotient property of logs. So remember that if I had like x to the 5th and divided it by x to the 3rd, that's the same thing as x to the 5 minus 3, right? So when you have a quotient here, it's the same thing in logarithms. If I have log base x of a over b, it's the same thing as log base x of a divided or minus log base x of b. Okay, same rule as the exponent. All right, so then we have the power property. You remember that if you take, you know, x to the 3rd to the 2nd power, you multiply those things. So the same thing here. If I have log base 2 of 6 to the 5th, what I can do is I can take that power and multiply it by the logarithm. So log base 2 of 6 to the 5th is the same thing as log base 2 of 6 multiplied by 5. We move the 5 out front just so we don't get confused, right? We don't want to put that 5 out in the back because it might look like a 65 or something else, so we put the 5 out front. Okay. So let's do some examples with these. Example 3 says, given that log base 3 of 7 is equal to 1.7712, approximate the value of log base 3 of 49. Okay, so can I write log base 3 of 49 in another way? Well, yeah, 49 is 7 squared, so I can relate that to 7, right? So I'm going to write it as log base 3 of 7 squared. Once I have this, however, I'm going to use my product property of a logarithm, and I'm going to say, okay, since this is 7 squared, it's the same thing as taking that 2 and multiplying it by the whole logarithm. So 2 times the log base 3 of 7. Okay, so power to a power, remember that we're going to multiply. Okay, so if I have 2 of these, I can simply put that in my calculator and multiply it by 2, or I can just add that to itself, and when I do that, you get approximately 3.5424. Okay, so we're using just properties of logarithms to estimate some of these things. So here we go, we have another one. This one's example 4. Notice that we have addition happening here. Okay, so this is saying they basically want us to solve this. So what we want to do is, let's see if we can simplify this a little bit. Since these logarithms were being added, can we work backwards? Okay, same log base, these were added. Remember, addition within exponentials has to do with multiplication. So this is the same thing as log base 7 of 27 times 3, which is 81. So I'm just simplifying this out. And then this one is the same thing as log base 7 of x squared, because this was 2 times x, and then with multiplication, it's a power to a power, right? So it's x squared. Now that my log bases are the same, and I've simplified this a little bit, I can drop these log bases, as we learned in the last lesson. So this is the same thing as x squared equals 81. Therefore, x is equal to 9. We don't say plus or minus 9 because we can't have a negative in there. Okay, so it's just positive 9. Let's look at 4b, and I'd love for you to try this one out on your own just to see how you're doing with it. But let's look at this. So here we're adding two logarithms with the same base together, which means we're going to be multiplying. Okay, so this is the same thing as log base 6 of x times x plus 5 equals, and here's just equal to 2. There's no logarithm on the other side. Okay, so then I know that if I wanted to simplify this out and get the logarithm out of there, I could say 6 to the second power is equal to that thing. So 6 squared is equal to, then I'm going to multiply that out. So that's x times x is x squared. X times 5 is plus 5x. Okay, so now I'm not dealing with a logarithm anymore. It's kind of nice. So this is 36 is equal to x. I don't know why I put a 3 there. 36 is equal to x squared plus 5x. So then to solve this is quadratic. So I'm just gonna set this to equal 0, right? So I'm gonna subtract 36 from both sides. And then we're gonna factor it. So 0 equals x squared plus 5x minus 36. Okay, we're gonna factor this thing. And then we're going to remember that we can't have a negative inside the logarithm. So if there's a negative factor here, which there will be, we're going to throw that one out. So two things that multiply to give you 36, add to give you 5. I should say multiply to give you negative 36, add to give you 5. So I believe that would be 9 and 4. So if I have positive 9, x plus 9, and x minus 4, those multiply to give you negative 36. Those do add to give you 5. Therefore, the 0 here is negative 9. The other 0 is positive 4. We cannot have a negative in our logarithm. We must use the positive, so 4 is our answer. Okay, so that's example 4b, and I think that's the end, you guys. So if you're having trouble with your logarithms, refer back to this video, watch the little jingle again, and I'll have the homework sheet ready for you guys in class. We'll catch you